Thanks for watching this screencast. The objective for this screencast is learners will be able to graph an inequality in two variables. So this is a review of a learning target that really you encountered in Algebra 1. We want to make a graph of what the inequality y is greater than or equal to negative x plus 2 is. And you might already have an intuitive an idea about how to solve this, but I want to just engage with this with you for a couple of minutes like this is the first time you've ever seen this problem. If I want to get an idea of what the graph of y is greater than or equal to negative x plus 2 is, maybe I should think about letting some x values happen and see what that means for y. So let me think about putting right here for x, think about putting x equals 0 in there. If x equals 0, then I get the inequality y is greater than or equal to, the opposite of 0 plus 2, which is just y is greater than or equal to 2. And I think I know how to graph y is greater than or equal to 2. If I think about when x is 0, I think about the y values being the values that occur here on the y-axis. So along here, which values for this x solve this? Well, it's all the ones that include 2, I'll put a filled-in dot, or the ones that are greater than 2, all the ones this way, 3, 4, 5, 5.2, etc. Let's try the same thing, but let me let x be 1 this time. If x is 1, then I get the inequality y is greater than or equal to negative 1 plus 2, which is the inequality y is greater than or equal to 1. So when x is 1, that's this vertical line here. And along that line, I want the y's that either are 1 or are greater than 1. So I want this, and I want all the stuff up here. Well, I didn't draw that very straight, but you get the idea. Let's do a couple more of these. Let's do x equals 2. If x is 2, I get the inequality y is greater than or equal to negative 2 plus 2, or y is greater than or equal to 0. So for the line when x is 2, I need 0 for y, or greater. Any of those points solve this inequality. What I realize is that a whole range of things, a whole series of ordered pairs will solve this inequality, not just a few numbers. Let's go back and do a negative value. Let's do x equals negative 1. This value here. When x is negative 1, y is greater than or equal to the opposite of negative 1, positive 1, plus 2, or y is greater than or equal to 3. So for x is negative 1, we've got this value. And I hope you can see the pattern. It looks like all of the what we might call boundary points are along the line equation y equals negative x plus 2, the line with a slope of negative 1 and a y-intercept of 2. So maybe we should try and draw all of those. This point would be a boundary point as well. So with this, and this, and this, the line itself would look something like this. There we go. And it looks like, for each of the x's that I individually chose, it looks like all of the points that are above that line should solve it too. So maybe I could just take with like a highlighter or something in here, all of these values in here should also solve the inequality. And that's exactly how this works. What you learned in Algebra 1 I tend to think of as a shortcut, but I wanted to take a minute and explain to you why that shortcut works. The boundary line is the line this equation looks like the inequality. We're going to have to make a decision about whether or not to include the line or not. And then we need to make a decision about which side of that boundary line is the side that solves the inequality. So we won't do this much work necessarily to graph the other ones today, but I wanted to engage with you for a couple of minutes about why what you learned in Algebra 1 works. Okay, here's another example. We want to graph the inequality y is less than 1/2 x minus 1. What I know about the boundary line is that it's going to be the line whose equation looks a lot like this inequality. It's going to be the line y equals 1/2 x minus 1. Think of that as like my boundary. So I know how to graph that line. That line has a y-intercept of -1. It's got a slope of 1/2, which means from this point that I know, if I go up 1 and right 2, continually I'll find other points on the line. When I'm making an inequality graph, I like to fill the whole space if I can. Should the boundary line itself be part of the solution here? It shouldn't, right? It says we want just the y's that are less than the line. So since we're not going to include it, the way I imagine you probably remember from Algebra 1, the way we indicate that is to make the boundary line dotted. And I like the arrows that indicate that's going to go both ways. Now, to figure out which direction I should shade my solutions here, maybe I'll think about doing the thing we did before, but only doing one of those things. Maybe I'll think about just what happens when like x is 0. When x is 0, half of 0 is 0, so I get y is less than -1. So when x is 0, right here on this line, I need where the y's are less than -1. I need all this stuff here. And that kind of tells me that this is the side that I need to shade. That's probably the simplest way I can describe to you to find the correct way to shade to indicate which side of this graph solves the inequality. Here's a different example. And the thing that's different about this example, given this inequality specifically, is that I don't have the thing already in the ready-to-graph form. What I might want to do is to solve this thing for y first. Maybe I'll think about subtracting 3x from both sides of this inequality. So -2y is greater than or equal to -3x minus 8. And then if I think about trying to solve for y, I guess I'd like to divide each side of the equation, or every term of the inequality rather, by -2 to get y here. The negatives would cancel here for 3/2 x, and -8 divided by -2 is a +4. And I hope that there's something that you're remembering, which is that if you divide an inequality by a negative number, we need to flip this inequality sign. This should be less than or equal to now. So, I think now that we have it in this form, we can make the graph of the inequality. This thing's going to have a y-intercept at 4. The slope is 3/2. You know I can't on this graph go up 3 and right 2. Maybe I should go down 3 and left 2 instead. Yeah, that'll do it. Down 3, left 2. Down 3, left 2. What type of boundary line do I need? This one includes the boundary line. I should make this a solid line. I missed a point there. And now, to decide where to shade, I'm going to think about maybe in this inequality, if I let x be 0, 3/2 of 0 is 0. So when x is 0, y is less than or equal to 4. So when x is 0 on this y-axis, y should be less than or equal to 4. I've already got the line for the equal to, but less than 4 is this way. So I want to shade this direction. This side of the inequality, any point in the shaded region here, or the part that will be shaded when I'm done doing it, any point in that region should solve this inequality. There we go. Okay, it's your turn. Panthers, solve this inequality. Try to make a sketch of the inequality graph if you can, and when you think you've got something that seems reasonable, hit play and we'll check it out. I think to solve this inequality, we would be best served solving it for y first. So perhaps I want to take this -10 and make it a +10 on the other side of the inequality. 4x plus 10 is greater than 2y. And then since I want y by itself, let me divide every term by 2. 2 divided by 2 is 1. So we get y on this side. I don't need to flip my inequality here because I didn't divide by a negative number. 4x divided by 2 is 2x. 10 divided by 2 is 5. Now, that's an okay way to write this, but we're used to getting line equations in the form y, the line would be y equals. In this case, I'd like to write it like y is less than. Notice the thing where if you switch the order, you've got to switch the inequality sign as well. Y is less than 2x plus 5. So here's our graph with a y-intercept of 5. The slope of 2 would be up 2 and right 1, but on my graph it might be easier to go down 2, left 1. Down 2, left 1, and so forth. This is a dotted line. This doesn't include the boundary line. So here's my dotted line. And which way am I going to shade this? Well, if I let x be 0, I get y is less than 5. I need this direction. I need all the stuff on this side of the line. Any point in the shaded region, but in this case not on the line though, should solve that inequality. There we have it. Thanks for watching.